Am I audible?
Yes, sir.
All right. Everything good?
Yes, sir.
All right. Any doubts from the last class?
So can you just like summarize real functions?
All right. See, very simply, what is a real function? If I give you any function y equals to f of x, all right. If all x and y are such that they are real numbers, all right. Any real number, it doesn't matter. If they are real numbers, then they are real function. All right. Now, what is domain of real function? All x for which y is a real number. All right. That will be the domain of real functions. This thing is clear enough?
Yes, sir.
So what is the first type of functions where you have to see the first function? Let's suppose this is x minus 1, all right, or 1 upon x. Whenever you see, we are going to learn about 2-3 types of function generally asked, all right. So first can be 1 upon x. This is rational function, right? Something upon something. Whenever you see this type of function, the domain will always be all real numbers except the values where this denominator is 0. So where will this be 0? At 0, right? Why this? Because 1 upon 0 is not defined. This thing is clear?
Yes, sir.
Fahad?
Yes.
All right. So whenever you see this type of function, how to find domain? See when this function is 0. When is x 0? Put x equals to 0. So the value at x equals to 0, this function becomes infinite. So domain will be r minus this 0. All right. This denotation is clear to all of you?
Yes.
Yes, sir.
All right. So suppose I give you a question. Find domain of y equals to 1 upon x minus 1. What will be the answer?
All real numbers except one. Except one.
Except 1, right? Enough? Clear?
Yes, sir.
Because at 1 this becomes 0 and that is not acceptable to us. Find domain of y equals to 1 upon 2 minus 3x. Solve this one.
All real numbers except 2 by 3.
Sure about that?
Yes.
All right. Enough?
Just a second.
All right.
Yes, sir. All real numbers except 2 by 3.
Absolutely right. So how we can solve this? Just put 2 minus 3x equals to 0. So x will be 2 by 2 by 3. So at 2 by 3 this becomes 0. So r minus 2 by 3 is the answer. Next question. And what are we finding? The domain, right? Why? Because no matter what value you put other than 2 by 3, this will always be, y will always be a real number, right? No matter what value you put, x equals to 1 0 0 you cannot put, 1 minus 1 5 minus 5 1 upon 2 pi root 3, right? No matter what value you put, this will always be a real number except 0. That is why we are doing this. Now f of x equals to 2x minus 4. Tell me the domain of this function.
So all real numbers except 2.
All right. This is Fahd. You answered or Arnav?
No, sir, all real numbers.
All real. All right. So you realized your mistake, right?
Yes, sir.
Fahad, your answer?
Yes, sir. All real numbers.
All real numbers. So don't forget, when we have this function in denominator, then we have to look for zeros. But this can be 0, right? If you put 2, then 4 minus 4 is 0. That is okay. 0 is a real number. All right. This thing is clear. Enough, Fahad.
Yes, sir.
Next question. 2 upon x minus 1, x minus 2. Think about this. All right.
So this is x minus 1 into x minus 2, right?
Yes, x minus 1 into x minus 2.
Okay.
So 2 and 1. 1 and 2.
So domain are 1 and 2.
No, all real numbers except 1 and 2.
All real numbers except 1 and 2. All right. Enough. This is clear.
Yes, sir.
All right. So what you can do, x minus 1 and x minus 2 is 0 when this will be 0, and x equals to 1 and x equals to 2. So all real numbers except 1 and 2. Next question. Domain of this function.
So all real numbers except 1, 2, and 3.
Absolutely right. Right. Similar question in the previous question we solved. I hope this is clear, both of you. Very easy. Solve this one.
All real numbers except 1 and 2.
How we can solve this?
So I put the value of 2x minus 3 upon x square minus 3x plus 2 equals to 1 upon 0.
All right. See, the idea is correct, but don't write like this. Like, don't put this is equals to 1 upon 0. That would be wrong. All right. You can write let x square minus 3x plus 2 equals to 0. Now we can solve. All right, Fahad?
Yes, sir, it's the same thing.
Not the same thing. See, if you put 1 upon 0, then this is already not defined, right? You cannot compare this with this. You must have
Okay.
seen like
Yes, sir. Yes, sir, I got
some
it.
memes in, yeah, some memes in Instagram, they write like 1 equals to 2, they try to prove. This is the mistake they do. Don't, you cannot even compare. All right. So write like this. Now you can factorize this. This is x square minus 2x minus x plus 2 equals to 0. So x minus 2 minus 1, x minus 2 equals to 0. So x minus 1 and x minus 2 equals to 0. So 1 and 2 are the values of x, where this becomes 0. So how we can write? The function f of x gets real values for all x except 1 and 2. So the domain of this function will be r minus 1 and 2. Clear, Arnav? Arnav, this is clear?
Yes.
All right, next question. F of x equals to x square plus 3x plus 5 upon x square minus 5x plus 4.
Sir, all real numbers except 4 and 1.
All right, everyone has this answer. Both of you are clear about this?
Yes.
All right, next question. F of x equals to 1 upon x square plus 3x plus 5.
Sir, all real numbers.
All real numbers. How did you solve this?
Sir, the roots would not be real. So,
Sorry, I did not understand part.
sir, the roots of this equation won't be real.
Absolutely right. So how we can do this? We can put this equal to 0, and in this quadratic equation, how to solve? We can write x equals to this quadratic formula minus b plus minus under root b square minus 4ac upon 2a. Now, if you look at b square minus 4ac here, this is 9 minus 20. So 9 minus 20 is minus 11. So negative. When discriminator is negative, the roots are not real. So x can never be 0. So all real numbers. This thing is clear, Arnav?
Yes, sir.
All right. Note it down if you have not. So this is type 1. All right, type 1 questions. When you have some denominator also, whenever you have denominator, like the variable in denominator, always look for zeros. When this becomes 0, that becomes 0, you have to eliminate that from domain. This thing is clear? Both of you?
Yes.
Yes, sir.
All right. So what is type 2? Type 2 is under root function. Y equals to f of x, which is equals to under root x. Now, whenever they give you under root, you have to notice that under root takes only 0 to infinite values. All right, under root can only take 0 to infinite. It cannot take negative values. This thing is clear? Yes or no,
Yes,
both of
sir.
you? All right. So under root can never take any value which is negative. So you always have to make this x as positive. So for this, domain will be x is greater than equals to 0 or 0 to infinite. If I write y equals to under root x minus 1, then what we can write? X minus 1 should be greater than equals to 0. That means x must be greater than equals to 1. So 1 to infinite is the domain. This thing is clear?
Sir, can you give another example?
And the example, all right. Sorry, what example did you? Another example, right?
Yes, sir.
So y equals to, suppose I give you 5x minus 3. You don't have to do anything. Whatever value, whatever this, I say this is masala, whatever masala is there in inside under root, take whole of that. This should be either positive or 0, right? That is the condition for under root. X should be greater than equals to 0. So I took this whole masala and write this as greater than equals to 0. This step is clear?
Yes.
So now this we can solve. 5x should be greater than equals to 3. X should be greater than equals to 3 by 5. So the answer is 3 by 5 to infinite. All right.
Okay.
I hope this is clear to both of you.
Yes.
All right. Now you have to know a little bit of solving inequalities also. So we are going to do a few parts according to the questions. All right. So try to solve this question. F of x is x minus 2 under root.
Two to infinity.
2 to infinite. Both of you clear?
Yes.
And close brackets on 2 and open brackets on infinite. I hope you remember about this interval scenes.
Yes.
All right. F of x is 5 minus x. Try to solve this one.
Five to infinity.
Careful. We have 5 minus x, not x minus 5. Right. You said 5 to infinite. So if I put 10, then this should be valid. So 5 minus 10 is minus 5, which is
Oh.
wrong. So think about this.
So 5 to minus infinite.
Yes, and that is not the way we say. We say minus infinite to 5, right? So how we can solve this? Yes, Fahad, you are saying anything?
No, sir, I was asking how to solve.
All right. So 5 minus x should be greater than or equal to 0, right? Now, if you take this 5 this side, this becomes minus x is greater than or equals to minus 5. Now, how did you do this? X is greater than or equals to 5, right? Minus minus plus, right?
Sir, I just used logic. I didn't solve.
Right. I know, but I'm asking the previously if you solved this enough. Did you do this? Minus minus plus,
No, sir, I just put minus x on the other side.
right? So that is a good way to do. If you do this minus minus plus, then this will be wrong. Why so? Now this starts some inequality chapter. All right, make a heading solving inequalities. All right, half portion of your this chapter is also going to finish in this. Whenever you are trying to solve inequalities, we have to remember that if you multiply with a negative number, inequality changes. What does change means? Greater than becomes less than and vice versa. All right. So if you have x is greater than 5 and if you are multiplying minus 1 both sides, so this will become minus x is less than minus 5. This thing is clear? Arnav, Fahad, this thing is clear?
Yes, sir.
All right. So again, if you have x is less than equals to minus 10 or minus x is less than equals to minus 10, then you have to write x is greater than equals to 10. If you remove negative sign, how do we remove negative sign? By multiplying negative sign on both sides. So if you multiply minus 1 to both sides, then this less than equals to will become greater than equals to. All right.
Sir, and what's the logic behind this change of
All
sign?
right. Surely, just think about this. If I write 6 is greater than 5, is this true or not?
Yes.
If I multiply negative sign, then minus 6 is greater than minus 5. This is true or not?
No, no. Okay, sir. Okay.
So you have to change because negative sign, the logic is that if you go from left to right, things increase in size. But if you go from right to left, then the more the absolute value, the less the number, right? I hope you get
Yes.
what I'm saying.
Yes.
All right. So this is the negative sign thing you have to remember. Now, second thing is wavy curve method. And this is a very lengthy topic that we are going to do in detail in inequalities chapter. Did you write this down, the first note? Both of you?
Yes.
All right. Wavy curve method, very detailed topic we are going to do in inequalities. Now I'm just going to give you hints how to solve. Whenever you see an equation in inequalities, follow the following steps. All right. If you see if you have x minus 5 greater than or equals to 0, this you can solve very easily. But if you have an equation longer than this, then you have to solve using this following steps. make coefficients or factorize the equation. The first step would be to factorize as many times as you want, all right, as you can. Then make coefficients of x positive. All coefficient of x should be positive. Change the inequality sign accordingly. Now the steps I'm going to explain, you don't have to write, just write it down first, then I'll give you an example how to solve. First step is factorize the equation, then make coefficient of x positive, change the inequality signs accordingly. Write it down. Done.
Yes, sir.
So let's see if they give you y equals to under root x square minus 4. All right. So y equals to x square minus 4 under root. What we want, all this masala should be positive. So I have to write x square minus 4 greater than equals to 0. This step is clear, both of you,
Yes, sir.
right? No issues now. First step, what is first step? Factorize. So how we can factorize x square minus 4? Any ideas?
A plus b into a minus b.
Absolutely right. So we can write x plus 2, x minus 2 is greater than equals to 0. Don't try to solve this as x square is greater than equals to 4, x is greater than equals to plus minus 2. Very wrong. All right, don't do this. Always follow these steps. Factorize. All right, and I'll write one more step in that. Factorize. Then the next step would be make the coefficient positive of the variable. So here x coefficient is positive, here also x coefficient is positive, so no issues. These steps are clear?
Yes.
Fahad and now, all right. Now,
Yes.
now starts the important thing. You have to write the factors for this. If you have x plus 2, this is 0, then x is minus 2, for x is 2. Now what you have to do, make a number line with these factors, minus 2 and 2, always in ascending order. This thing is clear?
Yes.
All right. If you had three factors, x minus 2, x plus 2, x plus 3, then you would have placed minus 3 also, but you don't have, so you don't have to. Two
Sir, but
factors,
we get the
yes.
same answers as if we did x square is greater than equal to 4. The answer is same.
How is it, like, what is the answer? Can you tell me?
The minus 2 and 2, and over there also we got minus 2 plus
No,
minus
no,
2.
no. We have not got the answer yet. See, we want to find all the values of x, right? If you put 2, then this becomes 0. If you put minus 2, this becomes 0. But there may be another value for which this be positive, right? This
Yes,
gives
sir.
us x is greater than equals to plus minus 2, which is wrong way to solve because x is either greater than 2 or greater than minus 2. So how is that possible, right? Getting my
Yes, sir.
point enough?
Yes, sir,
So
yes.
now, as soon as you write the factors in number line, what you have to do always plus, minus, plus. And don't worry, we'll go into very depth when we are solving inequalities. For few questions, you just have to know this. All right. Don't worry if it's not like crystal clear, but I hope this is clear, not very difficult. Fahad and now,
Yes.
all right. Always start from right, plus, minus, plus. Now you have to look which sign are we looking at, greater than equals to 0. That means positive. Which areas have positive signs, this and this. What this means, we have divided the whole number line in three parts, from minus infinite to minus 2, from minus 2 to 2, and 2 to infinite. Which area is positive, this and this. So the answer will be x will belong from this area is minus infinite to minus 2, close brackets, because we have equality sign, union 2 to infinite. This will be the domain. This thing is clear or not? Now you can check. If you put minus 3, so minus 3 square is 9, minus 4 is 5, under root 5 is valid. This thing is clear or not?
Yes.
Yes, sir.
All right, please note it down. And also, you can only apply this when the right hand side is 0. If that is not 0, then bring everything to one side, then factorize and repeat the same steps. All right. Done, both of you?
Yes.
Any doubts in this? No, I guess. So try to solve this question. All right. Don't just replace the value of like 2 with 5. Try to do this step by steps without looking at the previous question. All right. I'll give you 5 minutes for this. Think about this, solve this very clearly. Look at the steps, but don't look at the question we solved. All right, Fahad, enough. This is clear.
Yes, sir.
All right.
So what was the last step after making the number line?
You have to put plus minus plus, right, from the right side.
Yes, sir. After that.
After that, you have to look at what sign are you looking for. Is the equation says greater than equal to 0 or less than equal to 0? If it says greater than equal to 0, that means then this equation should be positive. So you have to take the part where you have put positive signs.
Oh,
All right. And you have to send me the answer in the chat and with proper brackets, open brackets, close brackets, and so on.
so square brackets means we are including the number, right?
Sorry, Fahad, what did you say? I could not like hear you.
The square bracket means that we are including the number.
Yes, square brackets means we are including the number. Open means we are not. And now, have you solved this?
Yes, sir. I also sent the answer in the chat.
Right. Let's see. X square minus 25 should be greater than or equal to 0. This is what we want. Now factorizing again x minus 5, x plus 5 greater than or equal to 0. Number line, because the coefficient of x are positive, minus 5 and 5. From the right hand side, positive, negative, positive. We want positive things. So minus infinite to minus 5, right? This area, minus infinite to minus 5, 5 to infinite. Union 5 to infinite. This thing is clear, both of you?
Yes.
All right, enough.
Yes.
All right. Let's solve few more questions on this. F of x equals to 1 upon under root x minus 1. All right, think about this question. Do not hurry. All right, there is no rush to solve this question. Just think about this and try to solve. Look at the question again, right? You cannot put all natural numbers. This is a mix of two questions, right? You have the function in the denominator. So you have to think about the first type of question also. All right. Have you solved this, both of you? And Fahad, I need the complete answer.
I don't know.
All right, let's see. See, we have mixed two types of question in this. First is under root, then 1 upon something, right? So under root says everything should be positive or 0. This says and this cannot be 0, right? Arnav, absolutely clear. Infinite cannot have close brackets. So under root says everything should be positive. 1 upon something says this cannot be 0. So what you can write, x minus 1 should be greater than 0, because we cannot put equals to 0, because this becomes 0 and this becomes infinite. So we cannot have 0 also. So we have to strictly say that x minus 1 is greater than 0. This means x is greater than 1. So if x is greater than 1, that means 1 to infinite. This thing is clear or not?
Yes.
All right. Next question. So you have to look for everything, right? Type 1, type 2, type 3, what are they saying? F of x equals to 1 upon under root 1 minus x. Few minutes for this also. Try to solve. All right. So both of you got the answer, I guess. So this is minus infinite to 1. And open brackets on both of that. Next question. Find the domain of the function defined by f of x equals to 4 minus x plus 1 upon under root x square minus 1. All right. Solve this, then think what we can do. All right. First, try to solve this individually. If this was the question and this was the question, how would you have solved? All right. Arnav, Fahad.
Yes, sir.
All right.
Sir, I've solved for them separately. So now what's ready?
All right, both of you have solved this. Both of you have solved this individually. Yes or no, Arnav, Fahad?
Yes.
All right,
Yes.
Arnav. All right. So for this, you must be getting minus infinite to 4 and close brackets on 4, open brackets on minus infinite.
Yes.
And for this, minus infinite to minus 1, open brackets, union 1 to infinite, right?
Yes.
All right.
Will we take the intersection of these?
Yes, intersection of this, absolutely. Now this set chapter comes to mind. See, one is saying you have to take, suppose, let me just try this. This is minus 1, 1 and 4. All right. One is saying you can take any number from minus infinite to 4. All right. All these values you can take. One is saying no. Let me just change the color of this. One is saying no, you can only take from this to minus infinite to minus 1, or 1 to infinite. So we have to take all the common areas. Which is the common areas? This part and this part. Because if you take any value other than this, like out of 4, and this is not very happy, right? This will face issues. But if you take any value which is not included in this part, suppose if I take any value in this, and this will be not be very happy. So you have to make both of them happy, take the common areas. So the final answer will be minus infinite to minus 1, open brackets, union, that means or 1 to 4. 4 can be included, but 1 cannot. This thing is clear or not, both of you? Now, Fahad, this thing is clear or not?
Yes, sir.
All right, Fahad.
Sir, I did not get how did you write this, the last one? Union.
Let me draw this again. This is minus 1, this is 1, this is 4, this is infinite, this is minus infinite. All right, the first part of the question says you can take any number from minus infinite to 4, right? Yes or no, Fahad?
Yes.
The second part says you can take any number from minus infinite to minus 1, right?
Yes.
Or you can take from 1 to infinite, right?
Yes. Sir. Okay, sir. I got.
Okay.
So, sir, can't we simply write it as minus infinite to 4 intersection?
No. See, if you write like that, the teacher also knows that you are trying to avoid solving that thing. All right.
Okay.
Yeah. So you always have to write this answer like this: from minus infinite to minus 1, common area, and from 1 to 4. Please note it down, the final answer, and draw the diagram also, so that you can know when to revise, like how to solve. Done, both of you? Yes or no, Fahad, Arnav?
Yes, sir.
All right. So domain is clear to, I guess, both of you, right? We are clear about that. What is domain of real function? All the values of x for which we get y as the real value. And we saw two types of questions. They generally ask that in denominator we cannot have 0 ever, no matter what. In under root we can never have negative values, right? If you see any function in denominator, then we look for zeros. If you have any function in under root, we put that as greater than equals to 0, right? Then we learned about wavy curve method. I hope that is clear. Why that is called wavy curve method? Plus minus plus. If positive is this wave, then this looks like a wave, like sine wave, cos wave. We are going to learn that in trigonometry also. So that is why this is called wavy curve method. Now, what is range of real function? The range of real function is the set of all real values f of x takes for all x in its domain. Write down the definition. I'll explain what this means. Done? Enough for this is clear. This is done. Noting down.
In just a minute, sir.
All right.
Done, sir.
All right. So what this means, if you have ever see a function f of x equals to something x minus 2, then they are saying if you put all the values of x here, whatever it like the domain is, then the set of all values that f of x gets, that means y we have, is the range. Very simple. In very simple terms, if you have domain as 1 2 3, if you put 1 2 and 3, all the values of y that we get is called the range. All right. Very
Oh.
simple.
Yes, sir.
So let's see how to solve questions on that. Very like standard steps are there to solve this type of questions. Find domain and range of f of x equals to 2x. So what is the domain of this question, this function?
All real numbers.
Absolutely right, all real numbers. Right, Fahad?
Yes, sir.
So domain is all real numbers. So obviously we cannot look for all real numbers and find y. So what we can do here, put y equals to 2x. Right? Instead of f of x, we can write y equals to 2x. Now, crucial step, you can note down also, write x in terms of y. Now we have y in terms of x, but we have to write x in terms of y. How we can do that? We can write 2x equals to y, x equals to y by 2. Yes or no?
Yes.
Now, what you have to do, think about this as the function. What is the domain of this function? What is the function of y by 2? Like domain of y by 2.
All
What
real.
values can y take? All real values. So if you can put all the values of y here, then you can say range is also all real numbers or R. Is this thing clear? This thing is clear or not? Enough, Fahad?
Yes.
All right. Suppose I give you another question. Y equals to 1 upon x. What is the domain here? What is the domain here?
All real numbers except 0.
Absolutely right. Now, how to find range? We have to write x in terms of y. Now take this as the function. What is the domain of this function?
All real numbers except 0.
So range will be that same domain, not this domain, domain of this function. And this is coincidence that both of these questions have same domain and range. This does not happen all the time. So don't say like this is always equal to this. No, this is just a coincidence. All right. You always have to find like this 1 upon y. All right.
Oh.
Yes.
All right. Write this down, both of the questions. Done.